Hi and welcome to Vision Mathematics. My name is Thomas Vanda. I'm going to take you through the lesson on this video. In this video on grade 12 trigonometry, we'll be looking at how to use the double angle formula in reverse. Let's go straight into the lesson. Lesson number 5. Double angle formulae in reverse. Let us have a look at the double angle formula in reverse. Starting with the sine one, we start with what was on the right hand side, just interchanging the positions. What was on the right comes to the left, and what was on the left goes to the right. The formula becomes 2 sine A cos A equal to sine 2A. Let's have an example to illustrate how we use that. 2 sine 15 degrees cos 15 degrees, that is equal to sine 2 times 15 degrees. And simplifying, that's sine 30 degrees, and then 30 degrees is a special angle, so we write down the value of the ratio, which is half. The one for the cosine, that's cos squared A minus sine squared A equal to cos 2A. Example, cos squared 22,5 degrees minus sine squared 22,5 degrees. Observe that the angle must be the same here and here. So that is simplifies to cos 2 times 22,5 degrees, and multiplying out we get cos 45 degrees. Again, this is a special angle, so its value is square root of 2 over 2. The second version for the double angle formula for cosine, 1 minus 2 sine squared A equal to cos 2A. Let's have an example of how to use it. 1 minus 2 sine squared 10 degrees equal to cos 2 times 10 degrees, which is cos 20 degrees. Now this is not a special angle, so if we are not allowed to use a calculator, we leave it there. The last version, 2 cos squared A minus 1 equal to cos 2A. And then illustration, 2 cos squared 15 degrees minus 1 equal to cos 2 times 15 degrees, which is equal to cos 30 degrees on multiplying 2 times 15. And this is a special angle, so cos 30 degrees is root 3 over 2. Here are some practice questions on the use of the double angle formula in reverse. Number 1, evaluate without using a calculator. 1.1, 2 sine 22,5 degrees cos 22,5 degrees. 1.2, cos squared 15 degrees minus sine squared 15 degrees. Number 2, simplify as far as possible without using a calculator. 2.1, 2 sine 10 degrees cos 10 degrees. 2.2, 1 minus 2 sine squared 20 degrees. Here are the suggested answers for the practice questions. 1.1 is 2 sine 22,5 degrees cos 22,5 degrees. We observe that this was our right hand side of the double angle formula for sine. So this is equal to sine 2 times 22,5 degrees. Multiplying here we get sine 45 degrees. This is a special angle, and the ratio sine 45 degrees is square root of 2 over 2. 1.2, cos squared 15 degrees minus sine squared 15 degrees. We observe that this was our right hand side for one of the versions of the double angle formula for cosine. So this is cosine 2 times 15 degrees, which simplifies to cosine 30 degrees. 30 is a special angle, and the ratio cos 30 degrees is root 3 over 2. 2.1, 2 sine 10 cos 10. We quickly recognize that this was our right hand side of the double angle formula for sine. So this is actually sine 2 times 10 degrees, which is sine 20 degrees. Without a calculator, we cannot simplify that further. 2.2, 1 minus 2 sine squared 20 degrees. We recognize that this was the right hand side of one of the versions of the double angle formula for cosine. So this is cos 2 times 20 degrees, which is cos 40 degrees. Again, without a calculator, we cannot simplify that further.
Sometimes a given expression in its original form is not suitable for the direct application of the double angle formula. So you have to perform some manipulations in order to make it suitable. This is what we are going to practice in the following examples. Looking at this expression on the left hand side, sine squared a minus cos squared a, it will remind us of the double angle formula for cosine. The difference is that the formula starts with a positive cos squared a and then minus sine squared a. So we have to perform some manipulations in order to make it suitable to apply the formula. So if we factor out minus 1, that's dividing by minus 1, it will change both signs. It will change this one to positive and change this one to negative. So factoring out and simply rearranging to start with the positive, we have minus into cos squared a minus sine squared a. Now this is exactly what the formula says, and this is cos 2a. So that's minus cos 2a. Let's now look at this one. 4 sine a cos a. This will remind us of the double angle formula for sine. The difference is that the formula has a 2 here. So we split 4 into 2 times 2 in order to create the 2 that is required by the formula. So we have 2 into 2 sine a cos a, which is equal to 2, this 2 here. And what is inside the brackets is sine 2a. Sine a cos a. Again, this will remind us of the double angle formula for sine. The challenge is that there is a missing 2 here. So to create the 2, we multiply by 2 over 2, which is 1. And multiplying by 1 does not change anything. So multiplying by 2 over 2, we create a 2 in the numerator there. That makes it 2 sine a cos a, which is sine 2a all over 2. Cos squared a. Now here, in order for us to apply the double angle formula for cosine, we need a minus 1 here. So in order to create a minus 1, we subtract 1 and compensate by adding 1. It's the same as adding 0, so we did not change anything. If you remember the methods we were using in completing the square. This part now is cos 2a. So we substitute cos 2a for this part to obtain cos 2a plus 1. For this one, I think we need an example. Let's work out an example. Evaluate 2 cos squared 15 degrees without the use of a calculator. So without the use of a calculator, if we look at this one, if you make it a double angle, multiplying this by 2, it will give us 30. So we see we have to use the double angle formula for cosine. Then we must manipulate this so that it gives us a double angle formula somewhere. So that's the 2 cos squared 15 degrees equal to 2 cos squared 15 degrees. We subtract 1 and add 1 in order to create the minus 1, which will allow us to use the double angle formula. Then we substitute for this with our cos 2a. So that gives us cos 2 times 15 degrees plus 1, and multiplying here we obtain cos 30 degrees plus 1. Now this is a special angle. We can now substitute for the trig ratio of cos 30, which is square root of 3 over 2 plus 1, and then putting this over one common denominator, we obtain square root of 3 plus 2 all over 2.
Let's now have some questions for your practice. 1. Without using a calculator, evaluate the following, leaving your answers in simplified set form where appropriate. 1.1. 2 cos 22,5 degrees sine 22,5 degrees. 1.2. 6 sine 15 degrees cos 15 degrees. 1.3. 5 sine 15 degrees cos 15 degrees. 1.4. 2 sine squared 22,5 degrees minus 2 cos squared 22,5 degrees. 1.5 minus sine 15 degrees cos 15 degrees. Question number 2. Show that minus 2 sine squared 22,5 degrees equal to minus 2 plus square root of 2 all over 2. Number 3. Show that 2 sine squared 15 degrees equal to 2 minus square root of 3 over 2. Number 4. Show that 4 cos squared 15 degrees equal to 2 plus the square root of.
Let's have a look at the suggested solutions for the practice questions. 1.1. 2 cos 22,5 degrees sine 22,5 degrees. Now this is the double angle formula for sine. It's only that here they interchange the positions of cosine and sine just to test whether you are observant. So I have just written it in the familiar way. 2 sine 22,5 degrees cos 22,5 degrees. And applying the double angle formula for sine in reverse, this is sine 2 times 22,5 degrees, which is equal to sine 45 degrees. And this is equal to square root of 2 over 2. 1.2. Sine 15 degrees cos 15 degrees. We rewrite this as 3 times 2 to create the double angle formula here. So that's 3 times 2 sine 15 degrees cos 15 degrees. Then this is double angle formula for sine. Applying that in reverse, we get 3 sine 2 times 15 degrees. This is equal to 3 times 30 degrees. Now sine 30 degrees is half. So that's 3 times half, which is 3 over 2. 1.3. 5 sine 15 degrees cos 15 degrees. We rewrite 5 as 5 times 1, and the 1 is written as 2 over 2 to create the 2, so that we have a formula for the double angle formula here. This is 1. So that's 5 times 2 over 2 sine 15 degrees cos 15 degrees. And rearranging, this is 5 times 2 sine 15 degrees cos 15 degrees all over 2. Now this is the double angle formula for sine. So this is equal to 5 sine 2 times 15 degrees all over 2, which is equal to 5 sine 30 degrees over 2. And starting with 5 over 2 here, we have 5 over 2, and putting in the ratio sine 30 degrees, which is half. So that's equal to 5 over 4. (1.4) 2 sine squared 22,5 degrees minus 2 cos squared 22,5 degrees. We observe that
In order for us to be able to use the double angle formula, we have to start with the positive cos squared 25 degrees, then minus sine squared 25 degrees. So this 2 has to be factored out, and in order to get rid of or to change the signs to make this negative and this one positive, we have to factor out negative 2. So factoring out negative 2, it will make this positive, and starting with that one, cos squared 22,5, and factoring out negative 2 makes this one negative, so that's minus sine squared 22,5 degrees. Now here we can now be able to apply the double angle formula in reverse. So that's our negative 2 here. Then this is equal to cos this is equal to cos 2 times 22,5, which simplifies to minus 2 cos 45 degrees. And substituting for the trig ratio of the special angle, that's minus 2 times square root of 2 over 2. The 2 cancels with the 2, and our final answer is negative square root of 2. 1.5 minus sine 15 degrees cos 15 degrees. We observe here that the challenge is the negative sign and the missing 2. So to create the missing 2, we must multiply by 2 over 2, which is 1, and does not change anything. It creates the 2 to help us to use the double angle formula. We just leave the minus sign here. Then that is minus 2 sine 15 degrees cos 15 degrees all over 2. Then applying the double angle formula, this numerator here is sine 2 15 degrees and all over 2 with our negative sign here. That simplifies to minus sine 30 degrees over 2. Now we can write this as, remember coefficient 1 here, so we can have that as minus 1 over 2, and sine 30 degrees is half. Multiplying the 2, we get minus 1/4. Question number 2, minus 2 sine squared 22,5 degrees. This will remind us of the double angle formula for cosine. The problem is that the 1 is missing here, because it should be 1 minus 2 sine squared 22,5 degrees. So to create that 1, we add minus 1 plus 1, which is a 0. That creates the 1 here. So we didn't change anything because this is a 0. Then we regroup. This becomes the right hand side of the double angle formula, one of the double angle formula for cosine. So keeping our minus 1, then substituting for that one, that is cos 2 times 22,5 degrees, and that gives us minus 1 plus cos 45 degrees, and that's minus 1 plus cos 45 is the square root of 2 over 2, and putting that under one common denominator gives the required result, which is minus 2 plus the square root of 2 all over 2. Question number 3. Here we choose to replace sine squared 15 degrees with 1 minus cos squared 15 degrees from the identity that sine squared 15 plus cos squared 15 equal to 1. Then, remembering that in order for us to use the double angle formula, we need a positive here. So we factor out minus 1, which will make minus 2 here when we multiply by minus 1. It will change this one to positive and this one to negative, and simply rearranging to start with the positive. That's minus 2 into cos squared 15 degrees minus 1. Then we remember again that we need a 2 here, so we can multiply the 2 inside, leaving the negative outside. So that's 2 cos squared 15 degrees. Remember, the 2 must multiply everything inside the bracket, minus 2. Then we are almost there. Our challenge is the negative 2 here. We need a negative 1 for the double angle formula for cosine. Since we have negative 2, we need to only split this negative 2 to negative 1, negative 1. That's keeping this as it is and splitting negative 2 into minus 1, minus 1. Observe that when you simplify that, it gives you that. So we haven't changed anything. But this now is the double angle formula. This one here. So we substitute for that using double angle formula. So that gives us minus cos 2 times 15 degrees. And this is that minus 1 here. And simplifying here, we obtain minus cos 30 degrees minus 1. Then we can substitute for the cosine of this special angle. So that's minus square root of 3 over 2 minus 1. Putting this under one common denominator, we obtain minus root 3 minus 2 all over 2. And multiplying the negative inside, it will change this to negative and this one to positive. So the final answer is what we were required to show, that 2 sine squared 15 degrees equal to minus square root of 3 all over 2. Here is an alternative proof for question number 3. We remember that if we want to use the double angle formula, which is 2 sine squared, it has a negative here. So we must create a negative there by factoring out minus 1 to change that to negative 2 sine squared 15 degrees. Then our challenge is that there is no 1 here because the formula is 1 minus 2 sine squared 15 degrees. So we have to create that 1 by adding minus 1 plus 1. So that's this minus 1 here. In the bracket we add minus 1 plus 1. Observe that this will be 0. So we did not change anything. Then regrouping, this becomes the right hand side of the double angle formula for cosine, leaving that minus 1 aside. So we can now use the double angle formula. That's minus 1 into this minus 1. This one will apply the double angle formula here. It is cos 2 times 15. So that gives us minus 1 into minus 1 plus cos 30 degrees. And multiplying the minus 1 inside, minus 1 times minus 1 gives us a positive 1. And minus 1 times a positive cos 30 will be minus cos 30. Substituting for the cosine of 30 degrees, we have 1 minus root 3 over 2, which can be put under one common denominator as 2 minus root 3 over 2, which is what we were required to show. Question number 4. The first challenge is that we need a 2 here, not a 4. So we split 4 into 2 times 2. Then the next challenge is that there is no minus 1. So we must create a minus 1 here by subtracting 1 and adding 1. So that's 2 into 2 cos squared 15 degrees minus 1 plus 1. Now this is 0, so we didn't change anything. So if we regroup that, this is now the double angle formula, which will allow us to use the formula now. So that's 2 into cos 2 times 15 degrees, then the plus 1. That's 2 into cos 30 degrees plus 1. Then substituting for cos 30 degrees, which is root 3 over 2, we have 2 into root 3 over 2 plus 1. and putting this under one common denominator, we have 2 into root 3 plus 2 all over 2. Then these 2 cancel, and the required result comes 4 cos squared 15 degrees is equal to 2 plus root 3.
That marks the end of today's lesson. Meet you in the next lesson. Bye-bye.